Hello everyone. This video will show how to determine the average rate of change of a function over an interval. In the examples that we're going to have, we will be given the function and we're supposed to determine the average rate of change given an interval. Please take note that in this interval notation that we have right here, this is represented as x and x. And the formula to determine the average rate of change is f of b minus f of a minus b over a. To better understand this equation right here, let's go over some examples. In this example, we're supposed to determine the average rate of change of this function right here over the interval 2 and 5/3. We first write the formula for the average rate of change. Using the given values that we have, we can tell that this interval notation that we have right here, our 2 is representing A, while our 5/3 is representing B. So we can go ahead and plug that into B and A in this equation. But the problem is that we don't know what is our f of B and what's the f of A. To do that, we first have to solve for these two. So we remember that our f of b is actually equal to f of the b value that we have there, so which is f of 5/3. So we go ahead and use this equation right here, or this function that we have right here, to solve for f of b, so which is equal to, so that's gonna be 2 times, we put in the b value, minus 3 times the b value plus 4. The answer to this will be our f of b. So we go ahead and simplify this. Notice that their denominators are not the same, so we can subtract or add them together. So what we do is we make their denominators the same. So I can go ahead and multiply a giant one for this. That's 3 over 3 to make it a 9. And I will multiply this by 9 over 9 to make their denominators equal to 9. So this would come out. Simplifying this would come out 41 over 9. Now let's move on to finding f of a. Our f of a is actually equal to f of, since our a is 2, so we put in 2 to the x's up there. So the expression would come out. Now we already have values for f of a and f of b, and we have a and b right there. So we go ahead and plug these values into the formula for the average rate of change. Since the denominators are not the same, we go ahead and multiply this by 9 over 9 and this one with 3 over 3 so that their denominators will be the same. So this would come out. So this comes out negative 13 over 9 over negative 1/3. So we go ahead, since this is a complex fraction, what we do is we flip the denominator and multiply across. So this would be 13 over 9 times 3 over 1, which becomes positive because both negatives make it a positive. So that means this comes out. This would be 1, and we can factor this one as 3 as well. So the final answer is 13 over 3. So this is the average rate of change over this interval. Now let's have another example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over this problem. This is our A and this is our B. We write the equation for the average rate of change. So we already have A and B, but we need to figure out what is f of B and f of A. So I go ahead and show the work up here. So f of B is actually equal to f of 3 because the B here was 3. So that is f of 3. So we go ahead and plug in 3 to the x up here. So this would come out. So f of b is negative 3 halves. Now let's have f of a. Our f of a is actually equal to f of negative 2. So we plug in negative 2 to the x right there. So this would come out. So our f of a is negative 3/7. So we go ahead and plug it into the equation up here. Two negatives make it positive. And then since we don't have the same denominator, I will multiply the first one with 7/7. And then multiply the second one with 2/2. So this would come out. Since this is a complex fraction, what we do is we copy the numerator, which is negative 15/4 times flip the denominator. That is that's 15/14. And that is 1/5. And then we multiply them across. So that is negative 15/70. Reducing this to lowest term, that is actually, we can divide this by 5. So that means there are 3 5s in 15 and there are 14 5s in 70. So the final average rate of change is negative 3, because it's a negative right there. So negative 3/14. Did you get the same answer as this? Good. Perfect. So that is how we find the average rate of change given the interval and a function.